So now I'm recording, and we're going to solve for cosine of x equals 1/2. So if I don't want to use my calculator or a rule, I'm still going to do the inverse cosine, but I'm going to use the unit circle to find those values. So I'm looking for places on the unit circle where my x value, because it's cosine, is 1/2. So my x value is 1/2 at pi over 3, as well as 5 pi over 3. So if you answer a question, answer loud so that the computer hears it. This is like really fun. Probably.
Are you sure?
We'll watch the video after we make it.
Okay. Sometimes it just records what's happening on the screen.
She said on the microphone.
I allowed the microphone.
Oh, then I bet it hears.
Yeah. So this gives me my values between 0 and 2 pi, but my domain is going to 3 pi. So how many more values do you think I'm going to have before I get to 3 pi?
1.
3 total, 1 more, okay? So if I look at my unit circle, I can't walk over there because it won't hear me anymore. A full rotation is how far? So how much farther do I have to go to get to 3 pi?
1 pi.
Half, so 1 pi. So which of my angles, pi over 3 or 5 pi over 3, did I pass in my second rotation? The pi over 3. So how far away is my new angle from pi over 3? 2 pi, because it's a full rotation. So I'm just going to add 2 pi to find my third. Okay. What is pi over 3 plus 2 pi?
7 pi over 3.
So
2 pi over 3.
2 pi is equal to 6 pi over 3. And so it is 7 pi over 3. What you got, Olivia?
Wait, so why are you adding 2 pi? 2 pi over 3.
So after I get to 2 pi, pi over 3 is pi over 3 away from 2 pi. Like pi over 3 more, if you will. And so between 2 pi and 3 pi, I have 7 pi over 3, which isn't written on my unit circle, but it's in the same exact spot as pi over 3. Okay, so this is my answer to letter A. I'm wondering if I should pause it and start a new video for letter B. No, one big video.
Just say we're moving on to letter B.
This is so.
We're moving on to letter B. Okay, so how is B different from A?
We have 2x instead of x.
We have 2x instead of x. So I'm going to solve exactly the same way. I'm going to do the cosine inverse of 1/2. But now instead of that being equal to x, what's it equal to?
2x.
So I have 2x equals the same thing, right? Any objections to this being equal to the same thing?
No.
Why is it equal to the same thing?
Because it's inverse cosine times 1/2. Or a 1/2.
Right, inverse cosine of 1/2 is inverse cosine of 1/2. They are equivalent. However, I just rewrote them. However, now this is equivalent to 2x. So what does this 2 do to the cosine function graphically? It changes the period, and it makes it go faster. So between 0 and 3 pi, I'm going twice as fast. So how many more values do you think I'm going to hit?
Twice as many.
Twice as many. So I'm going to hit 3 more. So before I can divide everything by 2 to get x by itself, I'm going to generate 3 more values so that I have twice as many.
So would you do 2 pi plus 5 pi over 3?
I absolutely would. So I'm adding 6 pi over 3 again. Why am I adding 6 pi over 3?
It's the same as 2 pi.
Because it's the same as 2 pi. So 5 plus 6 is 11 pi over 3. Now before I do any more adding, because adding is really hard, I'm going to look for a pattern because you guys are so good at identifying patterns because the MYP rubrics made you. So I've got 1 plus what is 5?
4 plus 2 plus 4.
So what's the next thing going to do?
Plus 2.
Plus 2. So I went plus 4, plus 2, plus 4,
13 pi.
over 3.
and then one more.
17. Yes.
Okay. questions about this? Yes.
Why are there 2 times as many values?
Because when I do my last step of dividing everything by 2, these are all going to be in my domain of 3 pi.
So would that be the same as how in the examples they multiplied like the interval by 2?
Yes. I just think that's confusing.
Okay.
So, how do I solve for x?
Divide by 2.
So I get what?
Pi over 6.
You can just turn all the denominators into 6.
I can just turn all the denominators into 6. That is perfectly true. So the very last thing that I want to do is check to make sure everything's in my domain, like I said it was going to be. Can I rewrite 3 pi as something over 6 so I can compare them easily? 18 pi over 6. So do I have anything in here that's smaller than 0 or bigger than 18 pi over 6?
Lots. Oh wait. No.
No, everything's within my domain, so I'm done.
Why is it smaller than 0?
Because 0 is my minimum
Oh, okay.
Sorry. I thought the question was, is everything
inside. Yes, everything is inside. Okay, so we are now going to do letter C. I don't want to copy everything. It won't let me just copy a little. So my original list of x values, I'm just going to rewrite them because they haven't changed, was pi over 3, 5 pi over 3, and 7 pi over 3, right? So now the only difference in letter C is what? There's a phase shift. I'm adding pi over 3. So my output values are going to be the same because the 1/2 hasn't changed. So now I'm going to write x plus pi over 3 equals pi over 3, 5 pi over 3, 7 pi over 3. Now how do I solve for x?
Subtract pi over 3.
So what do I get?
Which one?
0.
0.
4 pi over 3. And 2 pi.
So this is 6 pi over 3, which simplifies to 2 pi. Now, something that I want you to notice is that my pattern hasn't changed. Remember how we said the pattern was plus 4, plus 2, plus 4, plus 2, so on? So something that I want to check, because I changed my input of the cosine function, is that I can't fit any more stuff into my domain. So if my pattern is continuing plus 4, plus 2, what's this next value going to be?
10 pi over 3.
Because I'm adding 4, right? This was the difference of 4, 2, 4. So, similarly to what I did before, I want to check if it's in my domain. So how can I turn 3 pi into something over 3?
Well, that's about frequent for 3 repeating pi, right?
9 pi over 3.
Which, is this in my domain?
No.
No. So technically I didn't have to do that last step.
And then you can't have any on the other side, right? Because that one is the same.
Right, because 0 is the same. The one on the left didn't change.